Hello everyone. So today we're going to continue working with the probability of something happening, whether it be tossing coins, rolling dice, choosing a specific outfit based on different colors. So we are going to be figuring out how to count the different number of outcomes, and we're going to do so using tree diagrams. So our objective is to develop fluency with counting strategies to determine the sample space of an event. So how many different choices do we have of something happening based on the conditions we are given? So main question is, how can I construct and use a fluency table? We call this a tree diagram. And how can I use a fundamental counting principle to find the number of outcomes? Number 2 we'll be doing tomorrow. Today we're going to focus on how to draw a tree diagram and count the number or the different number of outcomes. So have you ever seen or heard, like on a Subway or Starbucks advertisement or any other campaign of a company where they are saying like, oh, you can have 10 different combinations of what you can eat, or a way to order your drink or your sub? So how does this happen? How is it possible that you have 10,000 different ways of ordering a drink or a sandwich? So when companies make these claims, they are using all the condiments as different ways to build a sandwich, whether you include mustard or whether you include mayo, whether you include lettuce or spinach. And whether you choose to include it or not, there's a lot of choices to make. And there's a lot of ways to serve a drink as well. What kind of milk are you going to use? Are you going to use cream or not? So this is how you end up with 10,000 different combinations, or even more than 10,000. So let's go ahead and look at these companies use these ideas of the tree diagram or the fundamental counting principle. So we're going to focus on tree diagrams today. So a tree diagram, you guys have a definition on your paper. You just have to fill in that one blank. A tree diagram is a diagram used to show the total number of possible outcomes in a probability experiment. How many different ways can something be made? So we are counting to figure out the total of how to make something happen. All right, so here's an example of a tree diagram with visuals. So this diagram shows that there are 6 different outfits from 2 pairs of jeans and 3 different shirts. So you can either have the beige shirt with the blue jeans, the yellow shirt with the blue jeans, the blue shirt with the blue jeans, or the same 3 color shirts but with a brown pair of pants. So there are 6 different outfits you can make from having 2 pairs of pants and 3 different shirts to choose from. There's different combinations we can make, and here the total is 6. This is what we call a tree diagram. Generally, you wouldn't actually draw the pants. You can just abbreviate, just put the word and put pants or blue pants, or just abbreviate with the B. All right, so let's go ahead and look at some more examples of tree diagrams. Some of them are on your paper and some of them are not. So this tree diagram has a total of how many outcomes? So we go ahead and count them. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So this tree diagram has 12 options. So let's try 12 combinations. So let's see what was our original options that we had. So our first choice was black sneakers, white sneakers, or red sneakers. So we had 3 choices. We had 3 options in our first choice. And then in choice 2, we had 1, 2, 3, 4. So once we chose the sneakers we wanted, we had 4 different caps we can pick from. So if I choose the black sneakers, I can do the red, blue, black, or tan cap. But if I choose the white sneakers, I have those same 4 options still. And with the red sneakers, I still have those same 4 options for my cap. So that gives me a total of 12 options in the end. So 12 combinations at the end in this tree diagram. So let's go ahead and see another tree diagram to see what this one is telling us. So here we have a coin being tossed. The H and T means the side with heads and the sides with tails. So here we are doing 3 rounds. So choice 1 is what does the first coin give me? Round 2, so again, heads or tails, when you toss it the first time. Then second choice is the second coin being tossed, whether it's a heads or tails. So once you throw the first coin, let's say you get heads, after that, the second coin can be heads or tails. Same thing with if your first coin is tails, it can still be heads or tails on the second coin, and then the third coin. So at the end of the day, this one has how many total options? We have 1, 2, 3, 4, 5, 6, 7, 8. So in this case, we have 8 different options of what we can get. We can get, let's go down the line on one of them. Let's say we get heads first, tails first, then heads, and then tails. So once we get to this very last branch right here, this is my final outcome. This represents tails, heads, tails of the 8 different options. Let's go ahead and look at some more tree diagrams. So here, let's say we're spinning something, a spinner that has 3 things it can land on, 1, 2, and 3. Spinner number 2 can land on 4, 5, or 6. And the outcomes are I can get a 1 with a 4, a 1 with a 5, a 1 with a 6, and then repeat the second outcome with the first outcome being 2, and as well with 3. So in this case, we have a total of how many outcomes? We have 1 outcome, 2, 3, 4, 5, 6, 7, 8, 9. So here we have 9 outcomes, or 5 choices we can make. So in this case, we have our outcomes. So the tree diagram will tell me how many I have. And we'll be drawing this in a minute. All right, so here we have another tree diagram. Tree diagrams can also be vertical, so go from top to bottom instead of left to right. In this case, it's getting a new car. So you can either choose a sedan, that's your first choice, or a station wagon. And once you make that choice, you can pick your car in one of 5 colors. So whether it's the sedan with black or the station wagon with black, and so on. And once you've made that second choice, your third choice is the trim on the car. You can get the GL, the SS, or the SL. Usually that means the different trims mean different types of things that the car includes, whether it has leather or it's a higher end or lower end. So again, in this case, we end up having how many choices when we can pick from 2 types of cars, 5 types of color, and 3 types of trim. So we have 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. So here we have 30 outcomes here that we can possibly have. So we can count a total number of 30 outcomes from this tree diagram, having 2 choices in the first option, 5 choices in the second one, and 3 in the third. So again, here's one more vertical tree diagram. Again, first you you flip a coin, heads or tails as your options, and then you roll a die, and you can get 1 through 6. So in this tree diagram, we have a total of 12 outcomes. All right, so fundamental counting principle, again, we're going to focus on this tomorrow. But again, the definition's right there that you guys have the 3 blanks to fill in. Again, if one event can occur in M ways, so there's an M, we don't know what number, it can be any number, whether it's heads or tails, that's 2, or die is 6. So M ways, so how many different ways can this thing give you a result? And a second event can happen in N ways, they're not going to be the same generally. Then the number of ways both events can occur is M times N. And you can always extend this to another event. So let's say there's a third option that's going to be in K ways, and then there's another one that's in W ways, and so on. All right, so we're going to go ahead and do some tree diagrams. Let's see. All right, so let's look at what we have. This is a new polo shirt is released in 3 colors, red, blue, and green, and 4 different sizes, small, medium, large, extra large. We're going to sketch a diagram to determine how many different color and size combinations are available to the public. So I'll do some of the tree diagrams sideways and some of them vertical. If you prefer one over the other one, just do it that way for all your examples. So I'll do this one with polo shirt going down. So there's 3 colors. Generally, you want to leave a lot of space in between them just so it won't get cramped as you go to the next level. So we're going to start with red. I'm going to put an R for red. I'm not going to write the whole word. I'm going to put a B. Notice I'm spacing it. And then green for G for green. So that's my first choice, right? This is choice 1. So it's red, blue, or green. For choice 2, we're going to pick 4 different sizes. So again, choice 2 would be the different sizes. So for red, I can choose small, medium, large, or extra large. Same thing for blue. I have the same 4 options if I choose the blue shirt, and the same 4 options if I pick the green shirt. Small, medium, large, and extra large. Small, medium, large, and extra large. All right, so these are my only 2 options for choices, color, and then the size. So now I'm going to go ahead and count my total number of options. So we're going to sketch a tree diagram and determine how many different color and size combinations are available to the public. So we're going to go ahead and count these now. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So we have 12 combinations that are available. So my final answer is 12 combinations. So this is my answer here, and I'm pretty much done. So again, you can do a vertical tree or a sideways tree. Let's go ahead and do number 2. So we have, you go to the snack bar to buy a bagel with cream cheese and a drink for lunch. So you have a few choices you can make. You can choose from a plain bagel, a blueberry bagel, or raisin bagel. So choice 1 is the type of bagel. So I'm going to put choice 1. I'll do another vertical one. So we can do plain. I'm going to put P for plain, B for blueberry, and R for raisin. Again, notice the spacing I'm making. And you can have a strawberry, onion, or plain cream cheese. So that's choice number 2 is the type of cream cheese I'm going to use. So choice 2. And again, you don't have to write the choice on the left. I'm just putting it for you guys to visually see it. So I have 3 choices to make. So I'm going to put 3 branches from each of these because I have 3 choices to make. So I'm going to have strawberry, onion, or plain cream cheese. Strawberry, onion, or plain cream cheese. Strawberry, onion, or plain cream cheese. Now from here, I'm going to choose my drink. This is a 3rd choice, which is the drink. And you can get water or a sports drink. So you only have 2 choices on this one. So each of these is going to have 2 little branches. That's why it's a good thing to space it as best as possible. Now you can always write the whole word, but then it gets very repetitive. So I'm going to put W for water, or S for sports drink. WS, WS, and then we're just going to repeat that a whole bunch of times here. 1 for each branch. And this is going to give me the total number of outcomes I can have. So I'm going to go ahead and count them. So it's 2, 4, 6, 8, 10, 12, 14, 16, 18. So I have a total of 18 outcomes. All right, let's go ahead and move on to number 3. So sketch the 2 diagrams to determine how many outfits are possible from a pair of jeans or khakis, shorts, and a choice of yellow, white, or blue shirt. And then we're going to say how many outfits will have a blue shirt. So let's do this one sideways. So choice 1 would be the type of pants. We're going to wear either jeans or we're going to wear khaki shorts. So I'm going to put a J for jeans and a K for khaki shorts. So this time I'm doing it left to right. And we have a choice of a yellow, white, or blue shirt. So we should have 3 branches because there are 3 choices after we make our first choice. So we're going to have yellow, white, or blue. Yellow, white, or blue. And that's pretty much it. There's just 2 decisions to make, the pants and the shirt. So we have a total of 1, 2, 3, 4, 5, 6. So there's a total of 6 outcomes, right? We have 6 outcomes. So now the second question is we're going to make sure we go back and answer our second question, which is how many of the outfits will have a blue shirt? So of the combinations, how many will have a blue shirt? So there's a B here and a B there, right? We can do jeans with a blue shirt or the khakis with a blue shirt. And we're going to say 2 outfits will have a blue shirt. And that's pretty much it for this one. Let's go ahead and move on to the next one. If you'd like to try them out and pause it and come back to it, feel free to do so. All right, let's look at the next one. We have Scott has 5 shirts, 3 pairs of pants, 4 pairs of socks. Sketch the 2 diagram and determine how many outfits he can choose with this. So I'm going to go ahead and draw it now. All right, so I'm going to do this one vertical just because it's easier because of the 3 decisions. I put S1, S2, S3, S4, S5 for the shirts. I put 3 branches off each one because we have 3 types of pairs of pants. I'm going to put P1, P2, P3 on these. And now I'm going to do 4 branches for these for the socks. So there will be 4 little branches on each of these. All right, so for this one gets a little crazy because there's a whole bunch of choices. So we are just going to stop here. I just wrote out the ones for the first one. So we can see that we have 4 here, 8, and 12, right? So we're going to have 4 more here. So let's just go ahead and use multiplication to do a shortcut. So I know there's 4, 4, 4. There's another 4 here, 4, 4, 4, 4. There's a whole bunch of 4s here, right? So I'm just going to count how many 4s we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 15 fours here, which means 15 times 4 gives me a total of 60 outcomes. Let's go ahead and draw the last one. Let's try it out, and we'll see what the answer is in a minute. So here we have first coin, heads, tails, and then we're going to toss another coin, and that one also has the options of heads and tails. And then we're going to toss it again. Each one has 2 branches, and heads, tails for each of these as well. Again, if you don't plan your writing out nicely in the beginning, it's not going to come out very pretty, but that's the general idea. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we have a total of 8 outcomes. And let's answer that question at the end. What is the probability of getting at least 2 tails? So we got to see which branches have 2 tails. The first one has all heads. The second one has heads, tails, so that's not 2 tails. The next one has heads, tails, heads, not 2 tails. The next one, this one right here, does have 2 tails. This one and this one. So this branch right here has 2 tails. Next one has 2 heads and a tail. This next one does have 2 tails, so it's this. There we have 2 tails. And then the very last one also has 2 tails. So we have a total of 3. 3 have at least 2 tails. And that's pretty much the general idea of drawing a tree diagram. Most important thing is organize your tree ahead of time, because if you don't leave enough space, you're going to have it all squished. All right, go ahead and get started your practice, and good luck.